So have a look up here, 4A.2, we're doing polynomial equality. And what we're saying, Noah, is if we've got the polynomial on the left equal to the polynomial on the right, then the coefficients of each respective term must be equal. So if I have here x squared, and over here I have ax squared, what does the value of a have to equal for these two terms to be equal? A has to be 1, right? What's the coefficient here of this term? 1. So the value of a has to be 1. How about for b? If we look at b, we've got plus bx and I've got minus 7x. So the value of b has to be minus 7. And then c is the square root of 3, positive square root of 3. Alright, so that's a nice easy one. All we're doing is saying which term corresponds on the opposite side of the equation. The coefficients have to be equal. Alright, let's move on to the second one. Here it's going to be a little bit more tricky. So again, this function is a quadratic, right? Because the highest power is a 2. So that means the x squared term has to be equal. So what that means is 8x squared is equal to 4ax squared. Alright? And so I just write the coefficients. Well, the coefficient here is 8, and 8 has to equal 4a. So what's the value of a that makes this true? A has to be 2. Divide both sides by 4, right? Okay, if we look at the next one, we have the coefficient here is b take 2, and the coefficient over here is minus 1. So we have b take 2 is equal to minus 1. To get b by itself, we will add 2 to both sides, positive 1. And then lastly, the constant term, what we have hanging out the side here, c take 9, well that's equal to, what's the constant term over here? Positive 5. And we'll add 9 to both sides to get c by itself. Okay, very good. So they were pretty okay. All we're doing, looking at the left, looking at the right, making the coefficients equal. When we get here, we can see, here we have the quadratic expressed in general form.
How does c equal 14? It's minus 4, isn't it?
C take 9, or is it C take 4? Did I write it down?
No. I got 14, because 14 take 9 equals 5.
C take 9, yeah, that's right. C take 9 equals 5. How do we solve that? We add 9 to both sides. C is 14. Yeah, no, you're good, cool, yeah. Okay, so on to this one. We can see they're expressed in different forms, right? Over here we have a quadratic, it's expressed in general form. We can see the highest power is 2. Here I have 2 linear factors, all right? Now, just as a side note, when you multiply linear factors, if we have x times x, that's going to give us a quadratic. So I can look at 2 linear factors, and you can now, and know that that's a quadratic. That's one way we can write. Now, we can't just go here, ax equals 2, all right, because this is not an x squared term. We must expand this first. We're going to fully expand it, and then equate the coefficients. So this is going to be a good opportunity for us to recap FOIL again. So FOIL says we multiply the first terms together. So I'm going to have ax multiplied by x. That's going to be ax squared. I'm going to have ax multiplied by minus 9. Okay, so we did the first terms together. Now we're doing the outside terms, right? The outside, ax times minus 9 will be minus 9ax. Okay, the inside terms, b times x will just be plus bx. And then the last term is going to be b times minus 9 will be minus 9b. Okay, so that's the expansion. Now what we're going to do is we're actually going to bring these together because these two are like terms. Alright, so the ax squared is going to hang out. And we have here, like x is common, right? We can see that they're like terms. And so if I collect them together, what have I got? I've got minus 9a plus b. I'm going to write it as b take away 9a. Alright, so I've done it reasonably quickly there, but hopefully you can see if we expand this, b times x and minus 9a times x, we're going to get exactly what we had above. Okay, so if we collect them, that's what it simplifies to. And the reason we do that is so that this is one coefficient. We've stated it as one bracket. And then we have over here this minus 9b hanging out. Okay, so remember, all we've done so far is expand it, and now we're ready to equate the coefficients. I have here ax squared is equal to 2x squared. So we've got a equals 2. Alright. Now, we can keep going along, right? I'm going to use the second bracket first, and then I'm going to make a case of why we don't even need to use that one. We can just jump to this one. So if I'm going to use this term, b take 9a, well, we've got b take 9a times x is going to equal the coefficient of x, minus 26. So we've got b take 9a is minus 26. I've got a is positive 2. Alright, which means if I put 2 there, I would have b take 9 times 2, b take 18. Alright, and then we'll plus 18 to both sides. We'll get positive, negative 8. Alright. So that's from equating this coefficient. This coefficient of x on the right hand side has to correspond with the coefficient of x on the left hand side. We already know the value of a, so we plug it in, and then we're just solving for b. Okay? By way of confirmation, if we look at the last term, we have over here minus 9b, that's the constant term, and it's equal to positive 72. Alright, to get b by itself, we would divide both sides by minus 9. 72 divided by minus 9, minus 8. Okay, so we didn't, you can see it confirms itself, right? There should be no contradiction, but in order to answer this question, we didn't need to perform this one here. We can just go a is 2, and from here b is minus 8. All we're trying to do is identify the values of the unknowns, a and b. Okay, we'll move on to the last one. Unless there's any questions. Alright, so we'll start just by looking and observing what's the relationship, and then there's a bit of expansion. So my fourth example, we've got 2x to the 3 Okay. Now if we're looking at this, we look at the left-hand side, this is a cubic, right? We can see the highest power is 3. We look at the right-hand side, and I've got a linear times a quadratic. I have a degree of 1 times a degree of 2. Alright, we're going to get a cubic as well. So we're starting to see some relationships there. Now, before we can equate the coefficients, we have to expand this, right? Now you can expand it any way you see fit. Alright, basically every term in this bracket has to multiply every term in this bracket. Now, it's my personal preference to have the one with 3 terms written first. So remember, order of multiplication doesn't matter. Alright, 2 times 3 is the same as 3 times 2. And so we can do that. We can just swap them around. That's just because it's my preference. I think it's a bit easier to deal with. And when we write out a sum in a moment, it's going to be more clear as to why. Okay, so now I'm going to expand it. I'm going to go in here, ax squared times 2x. That's going to give me 2a x to the power of 3. Alright, ax squared multiplied by 2x, 2ax to the power of 3. Okay? And then I'm going to do ax squared multiplied by positive 1. That's going to give me 2ax squared. Okay, so I've multiplied ax squared through. I've got 2ax to the 3, and then I've got 2 lots of ax, excuse me, not 2, just 1 lot, isn't it? Ax squared times 1 lot of ax squared. Alright, is that okay so far? Okay, next we're going to so we've multiplied a through, then we move on to the next one. Now I need to multiply b by everything in this bracket. So I'm going to go bx times 2x. Bx times 2x, that's going to be 2bx squared. Now if you want, you can keep writing it along here, but what I like to do is write it underneath here, 2bx squared. And the reason I've written it there is we've got, here's the x squared term, and I've got, when I multiply this out, another x squared term. I'm going to write them on underneath one another so we can just collect them together. It'll be nice and easy to add them together. Plus 2bx squared. So I might clear some of these arrows to show you. We've multiplied the a through, now we're multiplying the b through. So we did bx times 2x, 2bx squared. And now we're going to have bx times positive 1. So that's going to give me plus bx hanging out here. So we've multiplied the b term through. And now let's multiply c. I'm going to have c times 2x gives me 2cx. Alright. And then c times positive 1 gives me positive c. So we can see we've got this stacked thing, and the reason we've stacked it is because now it is just so easy for us to collect like terms. Alright, what this simplifies to, there's nothing to add to it. The leading term is 2ax to the power of 3. The x squared term is going to be a plus 2b x squared. Alright, do you see I've aligned them up so that when I collect them I can just write it like this. Okay? The same here, we've got bx plus 2c. So b plus 2c goes into one bracket, and then we have the c hanging out the side. Alright, so really there's two parts to this question, isn't there? There's the expansion and the collection of like terms, and now there's just the equating the left side with the right side. So on the left side, we've got 2ax to the power of 3 is equal to 2x to the power of 3. So that means the coefficients have to be equal. 2 equals 2a.
A equals 1.
A is 1, very good. We have a plus 2b. So the x squared terms is equal to minus 9. Now we saw a was positive 1, so we'll put that in there. Take away 1 from both sides. Divide both sides by 2. Alright, now, I was saying before, it's going to confirm itself, right? So we could use this term to get c, like we could equate x, or I can just go here I've got c, here I've got 6, c equals 6. Okay? So we can get it from the last one, we can get it from the middle one. This one's got to confirm it as well. C equals 6. If we want to get it from this one, let's check. We've got minus 5, b, I'll write out the whole thing. We've got b plus 2c is equal to, what's that number? 7 or 2? 7. B plus 2c is equal to 7. We've got b is minus 5. Add 5 to both sides. Divide both sides by 2. You see, it confirms it, although this one's much easier to see, right? C is 6, and we're just equating the constant terms. Alright, so this is exercise 4A.2. That was my plan today, right? Work through 4A.2. I want to see how we go with it. This is going to be a good one for practicing some expansion. So 4A.2, and yeah, have a go at the questions on the that are listed on the checklist there. They'll start easy, they will get a bit more complex.